Steve here with one more activity from topic 11. So this one is going to put together some of our ideas in a problem that we're calling family births. Okay, so here's the scenario. It says, suppose that a couple has 2 kids and that each child is equally likely to be a boy or a girl regardless of the outcome of previous births. Okay, so 50-50 chance of getting a boy or a girl, and they have 2 kids. So the question is, which scenario is more likely? Is it more likely to have 2 boys? Is it more likely to have 2 girls? Or is it more likely to have one of each? Okay. Now we're going to look at this. Just run through all our possibilities here, or a lot of the things we've talked about in topic 11. We'll do a simulation. We'll do a theoretical probability, and we'll do an expected value as well. So kind of putting together the big ideas from the topic. Okay. So the first thing is the intuition, right? What seems like it would be more likely? 2 boys, 2 girls, or one of each? Okay. A natural reaction, a natural way to think about this is to think that all these are equally likely, right? That you might think, okay, well, my sample space is 2 boys, 2 girls, one of each. Okay, and so there's 3 outcomes in the sample space. They're equally likely, so 1/3 chance of each occurring. Okay. Now there's a couple problems with that. One, we're being sort of circular in our reasoning, right? We're trying to figure out which one is more likely, and so we're sort of automatically saying they're equally likely by putting them in the sample space and saying they're 1/3 each. Okay. And the second issue is we don't really know that whether they're equally likely or not. Okay, so I'm going to attack this using some simulation first of all, and then we'll come back to our theoretical probabilities. Okay, so here's my simulation, right? Having a boy or a girl, there's a 50-50 chance of each occurring in a single birth. Okay, and that's similar to a coin flip. So I'm going to think of simulating the births as being via a coin flip. Okay, so for example, okay, here's my first trial. I should say I'm going to make heads be girls. Heads means a girl birth, and tails is a boy. Okay, so I tossed a head, so we had a girl, and then I'm going to toss it again, and we had another girl. So we had 2 girls, so that's a tally mark in the 2 girls box. All right, do it again. I've got a tail, so that's a boy. Heads, that's a girl, so we got 1 of each on that trial. Okay. Tail, boy. Heads, girl, so 1 of each. Okay, and so on. I'm not going to bore you with going through this 50 times, but I'm going to go do it 50 times. Actually, I'm going to use a website to do it for me. Okay, so I'm going to change my camera. I'm going to a website called Flip a Coin. And I'm going to flip 2 coins. And so here I'm looking at, let's see, I'm going to flip 2 coins 50 times. No, I'm just going to flip it 1 at a time. So flip, so there's 2 girls. Flip again, boy, girl. Or boy, girl. So 1 of each. Flip again, 2 girls, and so on. Okay, so I'm gonna just do that. That's a little quicker than physically tossing the coins. So I'm gonna do that, and then I'll come back to you when I've got my results. Okay, so I'm back. I finished my trials, and when I did it, what I found is that among all my trials, I did 50 trials total, and let's see. 13 times, I can just say 13 like that. 13 times I got 2 girls, 10 times I got 2 boys, and then 27 times I got 1 of each. Okay, so then we have our empirical probability, right, or experimental probability by calculating the proportions. So 13 out of the 50 times, or 26% of the time I got 2 girls, 10 out of the 50 times, or 20% of the time I got 2 boys, and 27 out of 50 times, or 54% of the time I got 1 boy and 1 girl. Okay, so 50 trials is not a ton of trials, but hopefully it's enough. And if you took the time to do the experiment, maybe you see that it becomes pretty clear that the probabilities are not equal, right? It's much more likely that you'll get 1 of each than that you'll get either 2 boys or 2 girls. Okay. And so the other thing that you maybe see is that, okay, when you have 2 kids, right, the only way to get 2 girls is to have a girl and then a girl. The only way to have 2 boys is to have a boy and then another boy. But there's 2 ways to have 1 of each, right? You can have a girl and then a boy, or you can have a boy and then a girl, right? So if we're thinking about our sample space and equally likely outcomes, right? Our sample space consists of, okay, we can have 2 girls, girl, girl. We can have 2 boys, boy, boy, or we can have 1 of each. But there's 2 ways that can happen, right? We can have a girl followed by a boy, or we can have a boy followed by a girl. And those are our equally likely outcomes, okay? And then our probabilities are easy to calculate, right? So the probability of getting 2 girls is 1 out of 4, because there's 4 outcomes. The probability of getting 2 boys is also 1 out of 4, and the probability of getting 1 of each is 2 out of 4, or a half. Okay? So it's much more likely to get 1 of each than it is to get either 2 girls or 2 boys. Okay? And just to be clear, let's write this as a probability distribution. Let's make our table, right? So we've got 2 girls, 2 boys, 1 of each, and the probability. Okay, not super neat here, but you get it. 1/4, 1/4, and 1/2. All right. So there's our distribution. So we've got our probability distribution. I want to go back to the problem. And we've answered most of the questions from the activity, but there's one more. It asks, what is the expected value of the number of girls in a 2-child family? Okay, and remember how we calculate expected values, right? We've got a rule for that, right? Or an idea, right? If you want to calculate the expected value for a numerical process, right? What you can do is you multiply the value of an outcome in the process by the probability of that outcome occurring. And you do that for each of your outcomes and you add them up. Okay? So we've got to do that in this case. All right, let me see if I've got my... Go back to my paper so we can write this down. Okay, so we found, okay, like we want to find the expected number of girls. So we have to phrase this carefully. Okay, so one outcome is to have 2 girls. So we'll say expected value of number of girls. Okay, one possibility is to have 2 girls. Okay, how often does that happen? Okay, it happens 1/4 of the time. Right. We can have 1 girl and 1 boy. Okay, so how often do we get 1 girl? We get that half the time. And then how often do we get no girls? That's when we have 2 boys, and we get that a quarter of the time. So our expected value of the number of girls is that sum. So 2 times a quarter is a half, plus a half is 1. Okay? And that's our expected value, okay, of the number of girls, right? And that's not surprising, right? If you have 2 kids and you have a 50-50 chance of having a boy or a girl, it's not surprising that on average you would expect to get one girl.